Alright, so going over the first example, find the maximum and minimum values of the, it said the objective function, which is all it means is the main function is the z equals 3x plus 6y subject to these constraints. I like graphing this in the same manner that I did all other examples, so I'm actually going to turn this into y equals mx plus b. So I have the first one right here, x plus y less than or equal to 18. Since that is a positive x, I'm going to subtract it to the other side. I get y is less than or equal to negative x plus 18. More specific, that is a negative 1 over 1x plus 18, so I know this is going to be a solid graph. Shading down, it is going to be a negative slope of 1 over 1, starting at 0, 18. So all that's the same. We just have to get it into this form. So this one is the same thing. That is a positive 5x. You would know it's negative if they specifically told you it was negative. So they will give you that negative sign, so there's no guesswork. So because this one is positive, I have to do the inverse, which is subtraction. It's going to cancel that out. Y is greater than or equal to a negative 5x plus 18. This one is the same, negative 5 over 1x plus 18. I have a solid line, shading down, negative slope of 5 over 1. This one is also starting at 0, 18. This one has a coefficient next to the y, so I'm going to have to do another step after I move this x over. So again, that x is positive, so I need to do the inverse by subtracting it to the other side. So that is right now a negative 1x plus 18, and this one's going to get a little messy, but what's math without some mess? Since this 5 is touching that y, that is understood to be multiplication. Every other symbol you'll see, so if it's addition, you'll see it like this. If it's subtraction, you'll see it like this. And if it's division, you will see it like that. So if you don't see any symbols, it's understood to be multiplying. The inverse of multiplying is to divide. So I'm going to divide the left side and divide the entire right side. Since there are two pieces, I've got to divide both of them. That way I can divide this x and the 18. So I get y is greater than or equal to negative 1/5 x plus, and as far as 18/5, as far as graphing that, I'm probably actually going to turn that into a decimal really quickly, just to get a rough idea of where that y-intercept is. So if I had my calculator handy, I'd be able to do this, but it's not bad. 5 goes into 18 3 times. 3 times 5 is 15. 15, 16, 17, 18. Add in that 0, it drops down. There's that decimal from here. 5 goes into 36 times with no remainder. So I know I am graphing at roughly 3.5. So obviously it's going to be a little bit more, but that just gives me an idea of like where I need to start graphing. So this is following the same steps as this. I have a solid line, shading down, negative slope. This time I am going 1 over 5, and my y-intercept is 0, 3.6. And as for the main equation, for the sake of getting it in y equals, I'm going to substitute 0 in for z. It's not going to change anything because 0 doesn't do anything. And I'm going to do what we did over here and get this y by itself. So I'm going to subtract my 3x over and get 6y equals negative 3x. Divide everything by 6 to cancel that 6x, that 6 out, excuse me. And negative 3 over 6 reduces to negative 1/2 x. And you can switch this around to actually have this in mx plus b form. So this one is an equal sign. So I know I'm just going to have a solid line with a negative slope and a y-intercept at the origin. So I have all my equations. From here, the original equation and these three, all this is saying is I want my x's to strictly be positive and my y's to strictly be positive. So thinking about a coordinate plane, I know my x-axis has the positive values here and the negative values here. So I need my x's to strictly be positive. That means I'm only looking at quadrants 1 and 4. But it also said I wanted my y's to be positive. And I know they're positive up here. And those two overlap in quadrant 1, which makes sense where all my x's are positive and my y's are positive. So I'm only looking in quadrant 1, which is why my grid it consists of positive x values and positive y values. So I just made one big quadrant 1 grid. And I'm going to graph all of these. So, got my paper locked down this time. Here we go. First equation, my negative 1/1 slope starting at 0, 18. So 16, 17, 18. Negative 1/1. So I'll probably pause this and connect all these lines. So I'm going to end up connecting all that line. That one's going to be solid and I'm going to shade down. So I'm looking at this area, so I'll get there. The next one, 0, 18, negative slope, so I go down 5/1. So here's one equation. Here's the second one. Down 1, 2, 3, 4, 5/1. 1, 2, 3, 4, 5/1. So automatically I know I'm restricted to this area because I need to be less than the big triangle and less than this one. So automatically I'm restricted to this little teeny tiny triangle right there. My third equation, oh, this one's greater than. I need to pay attention to that. So I'm actually got to switch this to the other side. Sorry if that confused you. So I'm down in the big triangle. And then I'm on this side of the second equation. So I'm going to erase this just for clarity. That's where those two overlap, so I know I'm restricted to just that area right now. Third one, this is greater than. That one is greater than. So I'm going to graph at about 1, 2, 3. I'm just going to eyeball 3.5. Slope is negative 1/5. 1 out to 5. 1 out to 5. 1 out to 5. 16, 18, they're about there. So I'm going to connect those guys. And that one says I'm shading up. So when I shade up, this part is irrelevant because it's not used with the last two, so I'm only going to worry about shading up inside my triangle, strictly above that line. So as you can see, that bottom triangle is no longer part of my solution, so I'm going to erase that out. It needs to be below this line, above this line, and above that line. So I'm restricted to this inside triangle right here. And as for my main equation through the origin with a -1/1 slope, -1/2. So the only reason I'm pausing is because if I graph that,